Hi, my name is Olga and I would like to walk you through my final exam of Data 605. Let's start from the first problem. I have generated random variables under required conditions and calculated required probabilities. The first one was the probability that random variable x is greater than the median of x, given that random variable x is greater than the first quartile of y. The second one, the probability that random variable x is greater than the median of x and that random variable y is greater than the first quartile of y. The third one, the probability that a random variable x is less than the median of x, given that random variable x is greater than the first quartile of y. Then I have proved that these two probabilities are equal. I have calculated join and margin probabilities and find the required probabilities. They appear to be equal. So as we see, this one is equal to this one multiplied by this one. Next task was to check if independence holds. Fisher's exact test and the chi-square test were applied. The p-value for both tests are approximately 0.7995, which is more than significance level 0.05. So we cannot reject the null hypothesis, and there is not enough evidence to conclude that events are dependent. Fisher's exact test is inappropriate when we have small sample sizes or highly unequal cell distributions. One can instead use chi-square test. The chi-square test is an approximation of the results from the Fisher's exact test. So erroneous results could potentially be obtained from the few observations. Okay, let's walk through the second problem. I have loaded required data sets of housing data, and let's look at the numeric variable distribution of the train set. We have just a couple of variables that have close to normal distributions. Other variables are highly skewed or have log normal distribution or just discrete variables. Okay, and the statistical summary of the train set presented here. It's quite a lot of variables. For further analysis, I have selected two predictors: overall quality and lot area. Let's look at this variable distribution, lot area, and house overall quality. We see that house overall quality is close to normal distribution, and house lot data are highly right skewed. Let's look at the scatter plot of sale price versus overall quality. So we can see strong positive correlation overall quality and sales price, which is quite expected. And transformed lot area looks also positively correlated with sales price, but this correlation is significantly not as strong as with previous variable. So as we see, correlation matrix confirms that. As correlation between lot area and sales price 0.26, and correlation between overall quality and sales price just significantly higher, 0.79. Okay, then I have done hypothesis testing and confirmed that correlation between sales price and lot area and correlation between sales price and overall quality are not equal to 0. Also, 80% confidence interval was calculated for both variables. This is for lot area and this is for overall quality variable. Okay, let's move to linear algebra and correlations tasks. So I have calculated precision matrix, then I multiply the correlation matrix by the precision matrix, then I multiply the precision matrix by the correlation matrix. So we see pretty much same result, and then I have conducted LU decomposition of the matrix. So we see that results. Next block is calculus-based probability and statistics, and above ground living area square feet was selected as a highly skewed variable, highly right skewed variable. I have checked that minimum value of this variable is above 0. So then I have run exponential probability density function and found the optimal value of lambda for this distribution. Then I have taken 1000 samples from this exponential distribution using this value and compare data distribution before and after the transformation. Fifths and 95th percentiles using the cumulative distribution function are almost the same as the empirical 5th and 95th percentile of the data. Also, 95% confidence interval was generated from the empirical data. Last section is model building. I have checked missing values first. As we see, there are lots of variables with missing values. And then I have applied MIC method for imputing missing values. I have decided to select top 10 predictors that correlates with the response of variables the most, and I have built model based on these variables. So what we see, that this model R square equal to 0.7958, that means that 79.58% of variance is explained by this model. We have a low p-value, which is less than 0.05, indicates that we can reject the null hypothesis. In other words, a predictor that has a low p-value is likely to be a meaningful addition to our model, because changes in the predictor's value are related to changes in the response variable. The strongest predictors according to this model are the following. Okay, and if we take the most important predictor, for example, overall quality, we can say that 1 unit increase in overall quality results in a 1.942 units increase in sales price. Residual analysis indicates that the residuals do not look normally distributed, and there is some pattern in residuals. They are not randomly spread around the horizontal line. That means that there is some useful information is hidden in residuals to be extracted, and definitely this model can be improved. Finally, I have made predictions. And submitted them to the Kaggle competition board. My name is Olga 3, and my score is 0.5, which looks quite low and quite expected. I think that, taking into account that we have lots of variables and they are quite highly correlated, so I would say that most likely the random forest or cubist, tree-based models should give much better results. So basically that's it. Thank you very much for your attention.